In this experiment, a solution of sodium thiosulfate was combined with a hydrochloric acid solution to create the illusion of a sunset. First, we cut out a silhouette of a sunset and placed it on the overhead projector with a petri dish placed on top. Next, we measured out 14 milliliters of 0.2 molar sodium thiosulfate solution. Then, we measured 8 milliliters of 1 molar hydrochloric acid solution. To create the sunset, first we added 14 milliliters of sodium thiosulfate solution into the petri dish. Then, the 8 milliliters of hydrochloric acid was added to the dish. A stirring rod was then used to stir the mixture. As the two solutions reacted, the mixture began to change color from clear and colorless to a milky white, and finally to a translucent orange. As the mixture changed colors in the petri dish, the projected image began to change color as well. The image changed from white to orange and eventually to black. We also decided to experiment with the procedure. In this trial, we did not stir the mixtures after combining them. We also added a few drops of phenolphthalein before adding the hydrochloric acid in hope that the basic sodium thiosulfate would cause it to add some purple to the sunset. The result, however, was not what we expected. The appearance of the mixture was relatively unchanged, other than a swirling pattern as the solutions mixed together and reacted. The projected image, however, changed dramatically. The sodium thiosulfate turned a very dark orange color as soon as the phenolphthalein was added, and once the hydrochloric acid was added, the mixture became dark brown. Instead of a sunset, the image now resembled that of a thunderstorm. After the experiment, be sure to properly dispose of the chemical waste. Also, be sure to carefully clean all of your equipment. This demonstration is possible due to the nature of the sulfur produced in the reaction. When sodium thiosulfate reacts with hydrochloric acid, the sulfur which is produced forms a colloid. Unlike in a true solution, the particles in a colloid are generally larger and therefore will scatter light that passes through the mixture. This scattering of light is called the Tyndall effect. As the light from the overhead projector shines through the mixture, the colloidal sulfur particles scatter the light. The changing colors is due to how much different wavelengths of visible light will scatter. Blue and green light, because they have shorter wavelengths, are scattered more than red and orange light, which have longer wavelengths. The longer wavelengths are able to pass through the mixture, which explains the appearance of the sunset in the projected image. However, as the sulfur particles grow in size and number, less light is able to pass through until eventually the mixture turns opaque, allowing no light to shine through, resulting in the projected image turning black.